Yo guys, and welcome back to another video. In the last video we took a look at packets, which are the low-level building blocks of our communication between client and server. Today we will focus on getting the game loop up and running. So what is this game loop? It's going to be that continuous thing running constantly in the background. We can kind of see it as the heartbeat of our game. Kahoot games, for example, have a clock that is ticking down. There's a time limit for how long you can take to answer. This game loop will run on the server and contain most logic of the game. We will simply tell our dumb Svelte frontend what it should show and hope that it obeys. We're also going to need some states, which will say which part of the game is currently running. Are we in the lobby phase, or are we maybe revealing the answer right now? This state will determine what the player or host is going to see on their screen and what their allowed actions are. So we're going to have the following states: lobby state, play state, intermission state, reveal state, and end state. Lobby state will be when the game hasn't started yet and is filling up with players. And here we will show the names of the players currently connected to the game. Play state is going to be the main state, so to speak, when a question is up on the screen and players can answer it. Intermission state is everything in between, for example when we are loading a new question or something like that. Reveal state is going to be run after all players have guessed or when the time has run out. Here we will simply show the correct answer and cause that ruckus in the classroom. Finally, we will have an end state, which is, as you might have guessed, run after the game has ended. And here we will proudly display the winner of the game and maybe a leaderboard or something like that. So these are the states that I'm thinking of. We're currently going to represent them with a simple enum, an integer value identifying what the current state is. This is not quite built in Golang, but we can use the iota keyword, which will create a bunch of incrementing number constants. But in TypeScript we will just use an actual enum because that is supported. In the future we might refactor this into a more fully fledged state machine where the states themselves actually contain the logic for what is supposed to happen in the game. We're also going to need something known as a Go routine, and I've touched very briefly on this topic in previous videos, but I want to explain it a little bit further now. The Go routine is one of the most amazing features of Golang, I personally think. They let us work with concurrent programming in a very easy fashion. Traditionally, we just have one thread, the main thread. And here the instructions are obviously executed in order. So what if we needed to wait a couple of seconds? What if we needed a timer? That would be very problematic if we only had the main thread to rely on, since we would have to block all the other code from running just to wait. And this is where we can use Go routines, which practically let us create a new thread to run code in. They are a bit different from operating system threads, but the concept is the same. If we run this sleep function inside a Go routine, that code won't affect the rest of our code. And this is what we will use for our game loop. Each game gets its own Go routine where it gets full power to do what it wants. So that should be everything we need to get going. Let's go ahead and write our game loop. Alright, so I went ahead and moved over this game.go file from entity to game. So this is where the actual game loop will live. And I also removed the current question integer, since we are not really going to be using that. But other than that, it looks pretty similar. I also added a function here to create a new game from a quiz. So I just provide a quiz. We generate a random ID for it, and we also generate a random code. So we just use the standard library function for generating an integer, and we start here at 100,000 so that we can get a 6-digit integer. So here I'm going to define a Go routine. This is in fact just an anonymous function which I use the Go keyword to make a Go routine out of. And then I use an infinite for loop, which might sound a bit scary, but All we do in here really is tick the game, which I created a function for as well, and then we also sleep for 1 second. So this will just keep on running each second. We will simply call this tick function. We don't really need higher resolution than that. We are only going to listen for the clock really. So we're gonna have a clock that ticks down, and when that clock reaches 0, depending on which state we are in currently, we will display a different state or something like that. I will also go ahead and define a new field called host here, and this will be the host of the game, the actual WebSocket connection to the host client, which we just provide when we create a new game. So I just went ahead and defined a new slice here of games, and this will be the games that this server is actually handling. So just define a new empty slice here, and down here when we want to host a game, first and foremost we need to convert this quiz ID that is part of the packet into an actual primitive object ID, and we try to parse that. If it's invalid, we just print out this error. Otherwise we try to get this quiz by its ID from our MongoDB database. And then we get back this quiz, and then of course we also need to check here if quiz is nil, then we want to return as well. So if we could not find a quiz by that ID, we also return. Otherwise we simply append to our games slice. So we have our game slice, and then we just append a new game where we pass in this quiz and the connection of the host. So I'm actually going to change this to be a pointer of games, since we want to be able to modify it. When we work with slices in Golang, if we wanted to modify a game in a slice, we would actually have to use the index of that element, and that is quite problematic. So in fact I'm just going to store an actual pointer to a game, and then we can use this down here to get a game by its code. So we loop over all the games that we have in net service. We check if game.code equals the code, then we return that pointer, otherwise we return nil if we have not found that game. So then I will define a new struct here in game.go for a player, and this will be the name of the player and then the WebSocket connection of that player. And then we'll just have a slice of these players in the game, so that are all the players that are connected to this game. Down here we can initialize this to an empty slice. So then here in the net service, when we get a connect packet from a player, we first try to find the game by the code that they provided, and then we call this function on player join, and here we pass in the name that they chose and their connection. So then we can actually do something with this. We have the name and connection, and then we can append to our players slice. So we have the name and the connection, and we create a new player struct instance. And then since we are using pointers here, of course, we also need to use a pointer then when we have created it. So we actually append a pointer instead of just a struct instance. So let's also go ahead and change up here in app.svelte a bit. So we have this code here, hard coded, and the name. Let's just insert the code that we insert here, and I also created an input field for the name where we bind that to the name variable, which we use here as well. So let's go ahead and try this out. If I first get the quizzes here and I host this, we can see that we get a new game with this code. So if I duplicate this, I try to join it, join game, then we can see test join the game. So evidently it went through all of this here. So we get the game by the code and then we join it, and then we can see that test join the game. Isn't that beautiful? So then I will define this enum, which I was talking about before. It's not really an enum, but it's just some constants here where we use the iota keyword. So this first lobby state here will have the number value 0, and the next one will have 1, 2, 3, and so on. And then I define a type alias for that, just to have a game state type, which we can use here. So we have the state, game state. Then we initialize that with a lobby state. So I think it's time that we also define another packet. We also need to tell the host or the player which the current game state is, so that they can know what they should show. So let's create a change game state packet. It's going to look something like this. And we also need to define a packet ID for that. I'm going to choose 3. I also think it's time that we should define some interfaces for our packets in TypeScript as well. So let's do that. We have a change game state packet. So here I will define that enum in TypeScript. It will just have the same order here. That is quite important actually, that we have the same order so that these numbers here are matching. I'll also go ahead and define an enum here so we can conveniently map these to these types here. So in app.svelte, and I can instead use packet types dot change game state. if the packet type here is changed game state, then I just cast this packet into a changed game state packet, and I will log that state. So let's also go ahead and try this in our backend. So now when a new game has been hosted, we will also send this changed game state packet to the host connection. So let's go ahead and try this. If I get the quizzes and I host this game, everything breaks. Okay, seems to be something wrong with the connection there. Let's try again. Okay, now it worked out fine. Not sure what that was about, but yeah, as we can see now, whenever we hosted this game, we also get a lobby state sent to our client. So this will just be for debugging purposes. We are going to clean up this code definitely in the future. We don't want to put everything in this app.svelte, but just for testing now, I'm making an if statement here to check if the state is -1. So I created a variable here for state, which I also set whenever we get the changed game state packet. Then we check if the state is 0, then we should show the lobby state instead. So now you can see if I press get quizzes and I host this game, we see lobby state instead, because that is our current game state. I think it will actually be problematic the way we have it right now, where game is part of its own package, because we really want to be able to communicate with the net service when we want to send packets and stuff like that. So I think we should move it to the service package, at least temporarily. We might refactor this later, but it will make things much easier now. Otherwise, we would have to have another intermediary package where we do some packet sending stuff, which might be nice, but let's just keep it simple for now. So we're going to make this like a service. We can't really use this nice syntax now since we're in a service package. We should probably do something like new game instead. Now we can use this with new game instead, so we just call this function, which is in the same package now. And we just call that game instead, since we had some conflicting names. But that should work the same way. The point is now that we can actually have some sort of field here which contains a net service pointer, so we can actually use that to send a package and such. And then we can pass in that reference. We have this C here, the pointer to net service. We just pass that into new game, which we set this net service to. So the point is that we can now use net service to send a packet also to the player. So the player should also know that the current game state is lobby. So let's go ahead and try this. If I host a new game, we get lobby state here. Then we can use this code to join this game. And boom, we can see we have different views here depending on if I am a host or a player. And I solved that really naively here by just having a host variable, which I set whenever we host it. So if we are hosting it, we just set that to true. And then in here, if the state is lobby state, we could actually use game state here, I think, game state.lobby. So if state is game state.lobby, we check if it's the host, then we show this host lobby state, otherwise we show you have successfully joined. So now we kind of want to tell the host about which players have joined the game, just like we have in the Kahoot lobby screen, we actually show the names of the players connected. So I think we also need to identify our players by an ID. So here I'll also add some struct tags for these IDs and names so that we can send them over the network. But I will add a little dash here to make sure that we're not trying to send the WebSocket connection or marshal that WebSocket connection in JSON. We don't want to do that. So we just only include ID and name. So then I create this player join packet where we just pass in a player object that we want the host to know about. And we also define a packet ID for that. So here I define this interface player join packet where we have this player field, and we also define a packet type player join. So then when a player has joined the game, we also send them to the host connection that a player has joined the game, and we send that player struct instance. And for this to work, we also need to define this a little bit in app.svelte. So whenever we get a player join packet, we cast that over into a player join packet. And then we create a little ugly array here as well of the players connected to the game. We just add to that array with the current player that has joined. And then down here we show a list of all the players that we have connected to the game currently. So let's try this out. If I try to host this game, we can see lobby state and we get a code. And then if I try to, with a name here, testing name, you have successfully joined. We can also see testing name show up here. So we can see that we get this packet here. I just noticed that this ID isn't that well defined. So when we create this player, of course, we want to do something like UUID dot new, I think. We should get a new UUID for that player. So now we actually need to have a way to start the game. So I'm going to define a new start game packet here as a packet type. We also need to define this in net service. And this will actually be an incoming packet. So we will send it from the client to the server. So we have to define this here and make sure that it's not taken by another packet ID. Then I'm going to create a function called start game where we just send that packet and a nice little button start game that we will show in the lobby state. So for this I'm going to define a new function here called get game by host, where we pass in a host pointer to that connection. So we want to find a game in our game's slice where the host is matching, and we need to do that because down here when we get this start game packet we need to get the game that this host is responsible for. So there are going to be multiple games running on the same server, and for example we don't want a player to be able to send a packet like start game packet. We only want to find this game where this specific connection is the host. So this is how we're going to do that. So check if it's not nil, and then I start this game. So let's go ahead and try this out. If I get the quizzes and I host them, and then I start the game. Boom, we can see that it starts ticking. I just added a nice little debug print here to say tick whenever we tick, and we can see that this game loop is working now. So our go routine is clearly working, and I can still do other things at the same time. So I'm going to create a new function here called broadcast packet, and we're going to use this to send a packet to all the players that are connected to the game. We're also going to add include host, so if this is set to true, we will also send this package here to the host. And let's also do some error checking here. We'll check these send packet errors. If they do exist, we just return early with that error. So I'm also going to create a function called change state, and this will just change the state and then broadcast a packet to all players and the host to say that we have changed the game state. And that is in fact what we want to do here in start. So we want to change the state here to play state. So for this play state we will show the current clock, which I will define soon, and then we just copied over this current question thing that I had previously just for testing purposes. If it's not the host, we just show press correct answer, and this is where we will have the buttons which the player presses to mark their answer. Then I will just define a new tick packet which we will send to the host to show them the clock. So I'll define a new field here called time. I'm just going to set it to 60 by default, and then when we tick we will just decrement that time field and send a packet, the tick packet, to the host. I'm going to define it here in packet types, and then we can use it in app.svelte. So case packet types tick. So when we get this tick packet we just cast it over into tick packet and then set the tick variable. So I'm just going to define a little delay here. I think maybe that is what is causing that issue I had with connection. And then I'm also going to send a question show packet just for debug purposes. Whenever we start the game, we change the play state and show a first little question. So let's go ahead and try this. So I get the quizzes, I host the game, we can get the game code here. I try to join here, you have successfully joined. We can see test here, I start the game. Boom, press correct answer. This is the play state, and in the host we can see we have the choices that the player can choose from, and we can see that this clock is ticking down. So now we made some really great progress in our game loop. There's definitely lots of improvements, especially on the front end side of things, where we need to really clean up this mess that we have created. But we have finally gotten a nice little game loop up and running, and this is what we can build upon. So in the next video we will add the ability to answer these questions, we will have reveal states and stuff like that. So I hope you guys enjoyed this video and that you learned something new from it. Feel free to comment your thoughts and opinions below, and feel free to join my Discord channel if you want to be part of the community. But other than that, I'll see you guys in the next video. Peace out.